All right, everybody. I think we'll go ahead and get started. First of all, I'm Dave Tilley. Just a few words on some logistics and thank yous, and then we're going to have a welcome from our chair, Dr. Bowerman, and then we'll get to our speaker. So we're going to be in here for an hour listening to Dr. Sabine O'Hara from the University of District of Columbia. We'll have some Q&A, and then when she's finished around 4, we have a nice tent set up thanks to the Dean of the College of Agriculture and Natural Resources, Craig Bayruti. And we'll have a panel discussion out there with 4 panelists on interdisciplinary topics. Have that go for about an hour. And then we have our social event with fish tacos are going to be set up. So hope you stick around for the full event. And we have name tags that will be available too as we go out there. This wouldn't be possible without the college, but also the department. Thanks to Dr. Bowerman for supporting this inaugural ENST Earth Day event. This was organized by myself with our marketing committee, Jonathan Stefanoff, Masoud Negaban Azar, Amro Hassanain, Dr. Annie Babaleri. I wrote the other names, Kimbra Petlip, Kimbra's here, Jocelyn Wardrop, Shannon Brown, Dr. Shannon Brown, and our alumnus Liz O'Keefe. So thanks to all of them for helping us get this together. So with that, I'm going to turn it over to our chair of the Environmental Science and Technology, Dr. Bill Bowerman.
Welcome. Thank you. Welcome to Earth Day. So thank you, Dave, and the committee for our very first Earth Day celebration, and hopefully we'll continue on. The very first Earth Day was in 1970, and Senator Gaylord Nelson from Wisconsin wanted an environmental teaching. And so they picked this week in April because everybody was up, not at spring break, there weren't exams, and everybody was still at the university across the country. And he picked Wednesday because there was the least conflicts. And it just happened to be John Deere's birthday. So each year there's a theme for Earth Day. And so actually last year's theme and this year's theme are the same. And the theme is invest in our planet. And there are 5 major programs that are set up for themes in these 2 years. The Great Global Cleanup, Sustainable Fashion, Climate and Environmental Literacy, Canopy Project, Food and Environment, and the Global Earth Challenge. So I'm delighted to have everybody here, especially our special guests and our keynote speaker, Dr. Sabine O'Hara from University of District of Columbia, and then our panelists that are going to speak with you today. It's no secret that we're living in a time where the natural environment faces severe challenges. That's why this day and this department is so important. It's our mission to better understand and protect the Earth for generations to come. You know, we are the land-grant university here in Maryland. And so we're here to use science and technology to save the world, solve the problems, and you're our problem solvers. So it's so essential with the things that we do in our department to find the solutions for our most pressing environmental issues, from researching renewable energy, farm waste management, to preserving precious species and ecosystems. We're committed to making a real difference. So today's celebration is an opportunity to recognize the incredible work being done in the department. And we have a wonderful lineup of speakers, so I'm sure you'll be inspired and informed by their expertise. So please join me in thanking them for taking part in this special event. Enjoy your day, and thanks for coming.
Before Dr. Sabine speaks, I would like to introduce her to you. Dr. Sabine O'Hara is a teacher, a mentor, a researcher, and administrator that is well known in her work in community-based sustainable development, urban resilience, and urban agriculture. She is currently leading an innovative PhD program in urban leadership and entrepreneurship at the University of the District of Columbia, UDC, which is another land-grant university. It's actually an exclusively urban land-grant university, the first and only one in the country. And prior to her current appointment, she also served as the founding dean of the College of Agriculture, Urban sustainability and environmental sciences at UDC. She also led the university's efforts to build a cutting-edge model for urban agriculture and urban sustainability that integrates research in agricultural, environmental, social, and health sciences with the practical aspirations of students and residents to embark on successful careers in the new green economy. Her work has focused on the quality of life and economic opportunity of local communities through these multidimensional intellectual, social, and physical capacity development. She was also the 10th president of Renault College in Virginia, and I believe the first female president of Renault College in Virginia, provost of Green Mountain College in Vermont, faculty member at Rensselaer Polytechnic Institute in Troy, New York, and as well as executive director of the Council for International Exchange of Scholars, which administers the Fulbright Scholars Program that many of you are familiar with. She did her studies in Germany, master's and doctoral degree in agricultural economics and environmental economics from the University of Göttingen in Germany. And she's a member of the working group on institutional analysis of socio-ecological systems at Humboldt University in Berlin, Germany, the past president of the International Society of Ecological Economics, and serves on the advisory board of King Abdulaziz University of Jeddah, the National Latino Farmers Association in Washington, D.C., and many editorial boards of academic journals. So with that, and of course, many other accomplishments that are not in this brief intro, please welcome Dr. Sabine O'Hara.
Okay, can you hear me? Yes. Okay, otherwise I'm going to put my classroom voice on. That will hurt too. It's a pleasure to be here. Thank you so much for the invitation to speak to you on Earth Day, this really important day. And so I thought I would start by reflecting a little bit on why is this such an important occasion. Namely, it asks us to sort of reflect a little bit about who are we? And who are we in relationship to each other and in relationship to the earth? So I thought I'd start with a few little stories of my own reflections. You heard I was born, raised, and educated in Germany, fell madly in love with a postdoc. That's another story. That's how I first got here, right? So that's how I first came to the United States with my American husband of Irish descent, as you can undoubtedly tell, right? That's the unusual combination of Sabine and O'Hara, which would not be your typical German last name. So my first encounter with my place was back in Germany, and the headlines at the time, you're talking 1983, were dioxins found in the breast milk of nursing mothers. And I was 7 months pregnant with my first son. So what's our place in relationship to the environment? Social and physical. The second story happened after I had moved to the United States. Now, if you know anything about good old Europe, right? No air conditioning. Very unusual. So this time of year it starts, right? The upside is, at least when you're in Northern Europe, usually the nights are cold. So we are just accustomed to closing the shades during the daytime and opening the windows at night. So I lived in upstate New York, Albany, and I taught at Rensselaer Polytechnic. And I was on one of my Saturday excursions after gardening, and I'm on my way to the mall, and I open the door to the mall, like, there's this wall of cold air hitting me. Do I really need to get my sweater in July? And it caught my attention, you know, I had experienced it many times, but maybe I was at the time, you're talking 92, we were in preparations for the Rio Earth Summit. Most of you are way too young to remember that, right? But it really struck me as, wow, Number one, is it really necessary? And number two, is it intentional? Is there an intentionality about keeping us from experiencing what our physical environment is like? Is there an intentionality about creating an artificial environment that is the same temperature, the same humidity year-round? Third story. Now, I grew up in, a very densely populated country. In fact, I always say to my colleagues at UDC, I was absolutely the predestined person to lead the United States only exclusively urban land grant, right? Because the econ and the agriculture that I experienced in my training, I think most of what sort of the southwestern part of Germany and Holland are doing in agriculture would be considered urban agriculture here. You're talking the difference between a country with a population density of 233 people per square kilometer compared to 33 in the United States. 33 people versus 233. That tells you something about the density and what that means for land use. And so here we lived in upstate New York, my first stop in the United States after I moved here from Germany, lived in northern Vermont. Wonderful. Felt a little bit like a kid in a candy shop, right? Except my first camping trip. I was scared to death. Okay, now you put me in the middle of, downtown Albany, where some of my colleagues say, really? Right? Or on the subway in New York, no problem. Because I'm used to a country with 233 people per square kilometer. I had never been out of hearing distance of civilization until my first camping trip in northern Vermont. And it scared me to death, right? No road noise, no church steeple, just noises that were unfamiliar to me. Oh, and then to make matters even better, my hiking and fly fishing aficionado husband said, oh, and by the way, there are black bears here. Well, I didn't sleep for 3 nights, okay, until I was back in civilization. So what's our compass? Who are we in relationship to the places where we live, where we work, where we interact? And if you've ever slept on a dock in the middle of a lake up in Vermont, wow, the stars. Incredible, right? No light pollution. No noise pollution, just the planets and the other planets. So who are we? Well, I'm going to make it a little bit more of an econ lesson from here on, because, that's what they didn't tell you, that I'm an economist, and by passion, because I think economics needs to change. This is how we value and evaluate all these relationships that I just described for you. Land is an input. Oh, and by the way, in most economic models these days, land, which used to stand for natural resources that are not human-made, land has been replaced. It is now subsumed under capital. Capital is everything that is human-made. So the assumption in eliminating land and saying, oh, all we need is capital, the assumption is that technology will solve all of our problems, and we will miraculously figure out how to substitute human-made things for nature, non-human, without any side effects. Really? But that's how value is assigned. And then, of course, there's labor. Well, with AI on the rise, that's going to be reduced to more and more of capital subsumed under technology. So these inputs are used to transform into what we call final goods and services. And by the way, this is not just theoretical, right? Because everything we measure and we watch all the time is final goods and services, the aggregate. That's GDP, incidentally, right? And we're really worried when GDP goes down, assuming that the sum total of all final goods and services produced is going to go down. That would be horrible, wouldn't it? Well, the problem is with this transformation process, there's also not only goods and services, there are also bads. There are emissions and waste. Do you notice anything about this model? It's just sort of like a bubble in space, isn't it? Where is the social context from which labor is drawn? And where is the social and environmental context to which emissions and waste are being released? Well, we economists have a fabulous term for all of this. These are externalities. And they're not in the purview of our evaluation process. So certainly we've seen the light, and we've seen the light since the Brundtland report. It's been a while since we came up with this notion of sustainable development, which suggests that there is more to it than the economy and more to it than this conversion process of inputs into outputs, where households purchase goods and services and firms purchase the inputs that then labor is paid for and therefore then has the capacity to buy goods and services, right? So we say, okay, there's more to it than that. There is a social context and there's an environmental context, and sustainability is this. Is where those three intersect in that Venn diagram. That's the balance we're seeking to strike. The first report, incidentally, only had two circles, the Brundtland report, environment and development. It didn't focus much on society and culture until the late 90s, when some folks said, wait a minute, this is not all one size fits all. But what's the role of social systems and cultures in navigating this intersection between the environment and the economy? And I think my own personal stories give you a taste of why that is important, right? I couldn't sleep outside in northern Vermont because I was used to a very different social context of a much more densely populated country with much more intersection between society and nature, not just society and the economy, which we kind of take as a given. So good reason why this third circle arrived. Now, I would suggest to you, if I had my druthers, I would take this out of every textbook, because it really looks like this. The economy is a nested system. We make it up. It wasn't just given on the seventh day of creation, and here it is. We make the rules. We say what has value and what doesn't. And we, the people, determine the social and cultural context that we shape. This is not a given. Now, when it comes to the environmental context, much more difficult, right? Because the rules of the planet, the rules of nature, not so easy for us to fiddle with. But this, absolutely. And I would encourage us to fiddle with it much more than we have. How do we assign value? How do we assess this context that we live in? So there's a really interesting story by Herman Daly, who taught here for a number of years. Some of you may have met him. He was one of my mentors early on in my career as an agricultural and ecological economist. And Herman told the story that he did this kind of diagram to the economy and the environment in a report of the World Bank. And the edited report came back and the environment box was gone. And all that was left was this. And he said, no, 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 no. You need to put an environment around that. The economy doesn't just function in nothingness. It's context-based. Well, they went back and forth with editing a few times and then decided no graphic would be included in the report. Because he wasn't able to nudge the economists to admit that the economy is a subsystem. And we tend to do it the other way around. We tend to say the economy is that thing outside that determines the value of everything else, and the environment is somewhere subsumed in that evaluation system. That's how we assign prices to ecosystems functions, right? Well, it's a little upside down, right? Because I have news for you. I'm not worried about nature. I am worried about my grandchildren and what climate change and disappearing ecosystem services will do in their life. But I'm not worried about the environment. So why does it matter? Well, it matters because models determine our value systems. If there is one indicator that we watch all the time, it's probably the GDP. What does it do? Is it going up? Is it going down? Well, remember, it's only all final goods and services produced. It doesn't tell you anything about this other elegant term called defensive expenditures. Now, what exactly are defensive expenditures? Defensive expenditures are what you need to expend in order to fix what we've ruined in the first place. So if acid rain in the 80s ate into the sandstones of all these beautiful gargoyles in European cathedrals, and you then have to hire all the stonemasons to fix the gargoyles, that's a defensive expenditure. Right now, we have plenty of defensive expenditures in the United States, which is actually going to show up as a plus in GDP because we've had floods, wildfires, all kinds of other climate events that are expenditures that then are called for to fix the damage. That's a positive in GDP. So it's not just, oh, what is this funny diagram looks like, right? The inputs going in, and it shapes our value systems. It shapes our mental maps. And clearly it determines policies. Because like it or not, if you want any action in the policy arena, you're going to have to conduct a cost-benefit study, don't you? To simply present people with scientific evidence about how these relationships between environment and economy work, that's not sufficient. You're going to have to make the case that in order for your intervention to be positively evaluated, you're going to have to create benefits that outweigh the costs of these interventions. So it also determines our strategy. So what kind of model would I suggest? Well, first start point would be to properly assess all the negative externalities, all these emissions and waste impacts. Here are just some from food production, right? 11% of US greenhouse gas emissions are related to food transportation alone, not any other transportation. 25% of CO2 emissions globally are attributed to food transportation. Those are all the fruits and vegetables we fly in and fly out, because we actually don't produce a whole lot of fruits and vegetables in the United States. We produce mainly commodity crops, and they get exported. And then we import fruits and vegetables from other countries, chiefly from Mexico, but also from very distant places. So globally, this whole go around emits 25% of CO2 emissions. Agriculture appropriates 70% of fresh water. 30% of food production is actually waste, right? These are negative externalities. My goodness, it's not just the food waste, but imagine the water, the fertilizer, the transportation, all of that has gone into that food. And now it's being wasted, and some of it never even leaves the farm, right? So let's start by assessing these negative externalities. And if we just needed a lesson in why it's a good idea to kind of rethink, maybe localizing things a little bit more and regionalizing things a little bit more would cut down substantially on some of these negative externalities. There's actually another upside to that, a social upside. And if we needed a lesson in that, COVID was it, right? The vulnerability of our supply chains and what that did to not just food products, but other products. And we're still reeling from that, right? I live in a condo on Connecticut Avenue in DC. I'm one of the fortunate people who can walk to work. And we still don't have the air conditioning on because some of the filters, that's sort of the annual maintenance before we switch from heating to air conditioning, are on back order. Well, they have been on back order for several months now. And who knows when that particular global supply chain is going to get unclogged so we can finally turn the air conditioning on, right? Lots of vulnerabilities that we really haven't sufficiently considered and haven't really sufficiently put into our assessment system of what is the value of these transactions. So here are some social externalities, because you see these environmental externalities are not distributed equally. That's where we get into things like environmental justice. They are distributed quite unequally. So in DC, just a little bit down the road from you, we did a study to look at food insecurity in the District of Columbia, which happens to be divided into 8 wards. Here's what some of the income distribution looks like in the district. Look at the high and the low. And DC is not uncommon. Many US cities look like that. Look at the unemployment rate. Right now, we're in a low unemployment state, right? Jobs are tight. Everybody is looking. So some unemployment rates are very low, but some remain stubbornly high. This is the percentage of single-parent households headed by a female. Low from 3.8%. That's Georgetown, by the way. And a high of 39% east of the river in Ward 8. And these are the non-Hispanic Black populations taken from the census. So stands to reason that this is not just coincidental, but this is a long history of disparities of these negative externalities, not just being equally distributed. But the brunt of the negative externalities are borne by those whose voices are not heard or rarely heard. So this is then how it looks in terms of food-related illnesses. The yellow is obesity rates of adult populations in the district. The red is diabetes rates. There's your food access, food insecurity, income distribution data in action as a social externality. So what to do about this? Well, we need a new mental map. We need a new mental map for our economy. And so here's one suggestion. This is, I've wrestled with how do I best depict this? And I see one of my students here. Hi, Campbell. Campbell knows this. I think that my strategy is to try to speak to the economists to pick them up where they are. So this is where economists are and have been, right? This is called efficiency increases. What you see here is the output level And what you see here is this cumulative input, this vector of all the different labor and capital inputs and so forth. And we say, as the inputs increase, so does output, but it kind of levels off. And those of you who are in plant production systems, you know that this often is true when you plot, let's say, corn yield and nitrogen fertilizer, right? You see something very similar. This is sort of a standard production function. And then we say what we want to do, what efficiency is we're pushing it up. We're trying to come up with new technology or new processes where the same amount of inputs now generates higher yields, higher rates of output. That's efficiency. Now, just interesting footnote, a lot of times we look especially for labor efficiency, right? Haven't seen so much about energy efficiency, unless you're in Europe and energy is really expensive. Haven't seen much about material efficiency. Can we lower the material throughput as we generate output? Usually we look at labor and the labor costs. So far, so good. So about Earth Day, this is where this arrived. Earth Day, 1970s and so forth, said, wait a minute, these negative externalities are creating problems. There must be a way of accounting for them better. And so here came these emission functions. Now that's a different proposition. Again, you have, so imagine you flip it, right? So these are your inputs, and every unit of input used generates output, but also emissions and waste. Now here the objective is different. The objective is, let's push it down. So that with each unit used, we're creating fewer emissions, less waste. That's an add-on to this efficiency picture. And we then sort of memorialize the recognition that something has to be done here to properly evaluate these negative externalities. We put it in place in the form of the Clean Water Act, the Clean Air Act, and other similar policy initiatives that said, wait a minute, can't keep going like this, because you see, this is a very different shape. This function doesn't level off. Often it runs away. Think of nitrate contamination of the groundwater, right? We keep merrily going our way, and all of a sudden we get these spikes. Well, that got me thinking, because actually, believe it or not, that was actually my doctoral dissertation many years ago now. And it is just a little bit disconcerting that almost 40 years later, we're still dealing with nitrate contamination of the groundwater. And I attempted to do a cost-benefit study on that when I still thought that was possible. But the externalities are vast. And so what you learn when you look at ecosystem services and how they work, how come we get these spikes? What happens in that soil layer between where the root zone ends and the aquifer starts? Well, that's probably the 90% of the picture that we rarely think about. I call it sink capacity. We value resources. And we especially value resources when they're turned into valuable goods and services. We recognize that emissions are creating costs. But what do we know about the planet's sink capacity? What do we know about nature's genius way of reducing these emissions, buffering them, absorbing them? That's where the real value lies. And I would suggest to you that might be 90% of the picture of the value that is not in our economic map, in our economic mindset. So what are they? Well, there are environmental sinks. We know them. The big ones, oceans, absorb CO2. Soils absorb carbon and other emissions. They get latched on to those minerals and at least for a time, buffer against emission spikes. Plants absorb CO2 and emit oxygen. Without them, we wouldn't be here. But it is astonishing how little we know about some of these sink capacities and what all these different factors are that influence them. What is a healthy sink versus one that's already declining? How do we know? What's the delta? And what are some of the factors that would influence it? Well, I would suggest to you there are social sinks too. That was my dioxin in the breast milk experience, right? Our bodies are sinks. But not just our bodies as individuals, but our communities are sinks. Did we learn what isolation means and how much stress it can create during COVID when we were all on lockdown and couldn't see each other? Yes, communities are sinks. They absorb our stresses. They nurture us back to health when things don't go so well. So our communities, our families, our collective social structures also are sinks. And those sink capacities too are disappearing because we increasingly operate in isolated islands rather than in communities. So this is a lesson in ecosystem services. How do they work? You've got all these sink capacities in a way covered here. Certainly the provisioning ecosystem service, and this is the nomenclature from the UN, right? The 4 categories of ecosystem services. Certainly the provisioning, that's very much the economic efficiency model. Output of food, timber, fiber, but then come the more difficult ones, these regulating services and these big supporting services like the hydrological cycle and the nutrient cycling. And the cultural ecosystem services, how do we preserve those? We are rightly worried about biodiversity disappearing because we know diversity stabilizes systems. We haven't even begun to pay attention to the rate at which sociodiversity is disappearing because we've created one mental map of efficiency. So I set out with a colleague, don't be intimidated by that, but I set out with a colleague who is a physicist and mathematician, and we said, can we show what the relationship is between this physical environment and this big social environment and the economy? And so we picked the hydrological cycle. And I'm happy to send you the paper. It was just published in Ecological Economics. And so here's what we did. We said, what is the distance from the Earth to the sun? Can't be more energy to drive the hydrological cycle than the energy from the sun that hits the Earth's surface. That's the max. What's the evaporation potential of that amount of energy? Now, why evaporation? Well, because ultimately that's what drives the hydrological cycle, right? It's 0.02% of fresh water that is actually in lakes, rivers, and streams. So there's a good bit in the solar, in the poles, right? In ice, but that's another story. And then there's most of it circling around as water vapor and so forth. So it's driven by the capacity to evaporate. And then where does it go? And we said, well, let's just look at the big stuff. The biggest is agriculture. Agriculture absorbs 70% of fresh water. Roughly 20% goes for manufacturer industrial purposes, and roughly 10% for households. And we said, let's see if we can get a social component in here and look at high water users and low water users. So that's the low use and the high use, and then the percentage of the population that uses either high or low. Okay. So this is what we found. We've done this for 5 countries now. This is the United States. So this is where we currently are. That's our GDP. Now, what you see here is a plot of all possible GDP levels that can be attained from this algorithm. And here you see the percentage, this is the GDP, and here you see the percentage for industrial water use and for agricultural water use. And all the other variables are in the algorithm, right? So we would call this a landscape of GDP potential. Now the question is, how do we go from here to here and here rather than downhill? And so here's what we found. You can only climb up that hill of economic capacity increase if you save water. You go look at it and figure out the percentages of industrial use and agricultural use, and there is no combination at the high end that gets you up the GDP slope. What gets you up the GDP slope is combinations where some water is left over. A considerable amount of water is left over. In excess of 60% is left over. We've done this for China, India, the United States, Germany, and Russia. They all look very different. The slopes all look very different, which is what you expect. Different climate conditions and different degrees of efficiency, particularly in the agricultural sector, which is your big freshwater user. The other thing we found is that there is no process of evaporation that we humans have been able to come up with that's as cheap as how nature does it. So that would suggest that not only the use of resources is valuable, but actually saving resources may be more valuable. Because we need capacity, ultimately energy, that provides that capacity to keep these big cycles of Earth going. We need energy capacity not only for the allocation of fresh water here and there and everywhere, but to keep the cycle itself going. So there is an appropriation of energy that is necessary to sustain these big ecosystem services that we are blessed to benefit from, which might explain why there's no water on Mars, or at least not anymore. Maybe somewhere along the way, that processing capacity got wrecked, or on Venus, or on a whole bunch of other planets, where maybe we didn't calculate that it's not just the energy for the uses we define, but for the uses that planet needs to maintain ecosystems capacities. So we need energy for more than simply transforming our resources in our desirable goods and services, but to maintain processing capacity. So these are some of the key findings we've come up with so far. I'd love to work with some of you to look at some of the other big ecosystem services. Nitrogen has got to be really exciting because there's so much of it floating around, and it is involved in so many different sink capacities. So who are we? And how do we interact with each other and this big place around us that we call our planet? Thank you all.
So time for questions and answers. Thank you.
I don't know about answers.
Thoughts?
Yeah.
Well, thanks very much for our seminar. Just one quick thought. When we use resources, we can assign the value to an individual or a company of individuals. And that's economics. But who do we assign the value of saved resources? And what would be the motivation of saving them?
Yeah, really good question. So this is a big discussion about economics and economic philosophy, right? Economics started actually as a moral science. Comes out of moral philosophy. What they don't tell you in your first econ course is that Adam Smith, who is said to be the father of market economics, was a Calvinist. And he said, the allocation of the market is incredibly efficient. And I don't quibble with him about that. It is incredibly efficient, right? These individuals interacting in this marketplace, thousands and millions, by way of saying, here's what I want and need, here's what you can give me, right? And we come to an agreement of this transaction, incredibly efficient and incredibly compelling if you think about what was before. Before was feudalism, not a great system of somebody at the top telling all the rest of us what we can and cannot have and do and don't do, right? That was Adam Smith's observation, the power of the allocation mechanism of the market within a moral framework of compassion. That's what he called it, good Calvinist that he was. The environment was not so much on his radar screen, but society was, absolutely. And so he said, it is the responsibility to set the moral frame for the market. And for him, that moral frame was compassion. So for us, where we have a planet not of, I don't know what it was in Adam Smith's time, but maybe 1.5 billion or something, right? And now we're 8. So maybe it's time to discuss what does this moral frame look like for a planet of 8 billion people? And what is our responsibility to conserve these resources, not so much for our own use, but to keep the planet going?
First of all, thank you. It's great to see you after a while and great presentation.
Thank you.
Appreciate that. One of the dilemmas that I usually hear coming from a very poor farming background, small farms and so forth, is that provisioning component that everybody is after basically producing something that they can survive. Then you take that into parts of the world that people don't have investment necessity. For example, in the case of water, invest in irrigation technology with high efficiencies, or conveyance canals, line canals that we can lose this water, the loss, waste of the water. So that's where I think the equations don't come together. So most of the births happen, exponential births, population dynamics, occur actually in the societies where it's actually they're very poor already. And then we need more food to feed more people. So the dimensions globally sometimes, I was really interested in, I will read your paper that for these different countries and how that looks comparatively for poor countries where they don't have these technologies to make the efficient use of resources to decrease the waste, or even to have technology to have recycling and bioeconomy, recycling, not always, circular bioeconomy. So did you all discuss this?
So the first question I would ask is, how do we account for the value of output that your subsistence farmers produce, right? Because we don't. If they eat it themselves and they share it with their community, their value is 0. It only turns into value when it's a commodity crop that is actually sold. So that's the first question I would ask is, how do we properly account for the value of the products we produce, right? And then your resource allocation changes, because then it becomes competitive to allocate resources to some of the subsistence output as opposed to the commodity output. The second question is when you have the commodity output in a distributed system of small farmers. No cold chain or much less of a cold chain, no transportation or much less of transportation, right? So then let's put into the accounting system all these other, what we call indirect and induced economic effects that become necessary because you've just added a whole bunch of other transactions that become necessary because you're producing commodity crops and not subsistence crops, right? So when it comes to the value of resource allocations for different economic purposes, it's been comparing apples and oranges. Because some transactions are valuable in the marketplace and others are not, right? And so the first thing we need to do is kind of level the playing field a little bit and say, okay, so how do we better account for the output value of subsistence production or distributed production, right? That's another interesting thing. I think we're starting to get there through this whole discussion about resilience. Because we've just discovered that maybe the definition of scale that we currently operate under, namely scale means bigger, that maybe that's a very vulnerable definition of scale. And what scale might need to morph into is multiples are scale. And not one big operations, but multiples of smaller operations. But we simply have done a pretty lousy job in accounting for non-market contributions, including contributions to risk.
All right. I think in the interest of time, we'll take our, we'll go outside for our panel discussion. But again, let's thank Dr. O'Hara for being here and giving us a great.